Welcome back to Blockstream Talk. Today we're speaking with Christian from the Blockstream Research team about Simplicity, a blockchain programming language so simple it actually fits on a t-shirt. Christian runs us through an introduction to Simplicity, and we also discuss why Dr. Adam Back calls Simplicity the last soft fork of Bitcoin, one soft fork to rule them all. We also talk broadly about some of the applications and benefits of smart contracts on Bitcoin, and why that's better than running smart contracts on layer 2 solutions like Liquid. And also what kind of pushback and concerns Christian has bumped into so far. Simplicity has been around for about a decade already, and Christian guides that implementation could be another 5 or even 10 years away, depending of course on community support. It's really interesting to see how low time preference the Blockstream Research team is, and how they're really playing the long game in terms of Bitcoin development. Enjoy the show and let us know what you think in the comments below. Christian, thanks for joining us on the podcast today.
Thanks for having me.
To start off with, can you tell us a little bit about your role at Blockstream and what your background in computer science is, and what's the path that brought you to Bitcoin?
For sure. So I'm part of the research team, and where I mainly develop Simplicity and a little bit of Miniscript and zero-knowledge proofs. My background is computer science, as you might have guessed. So I'm a master graduate from TU Dresden in Germany. My bachelor was general computer science, and my master's was computational logic. So I'm a logician by trade, and we mainly worked on roots of inference, databases, knowledge graphs. A professor, for instance, was one of the heads behind Wikidata, which you might know, which is the knowledge graph behind Wikipedia. It's a little bit different than Bitcoin. So what brought me here? It's an interesting story. So it's El Sirian, an old friend, and he's been involved in Bitcoin, since a long time. And we've been talking about Bitcoin for many years, but it was on the side most of the time. And at some point, he had this Simplicity T-shirt, and I was intrigued. I looked at these symbols, these rules of inference. They look very similar to logic. And Simplicity is formal in nature, so this was similar to what I've been doing. So I looked at it, I was intrigued, I wanted to understand this, right? We crowded around, not just me, we tried to make sense of it all. And at some point he said, well, if you're interested, why not do an internship at us, at Blockstream? Why not come to Blockstream? We're looking for people. And I took a while, maybe a month, and then I wrote Andrew Polster an email about my background. I'm interested in this thing. I'm interested in cryptography. It's been a hobby of mine, but not really a main job or anything like that. And so this is how it started. And so it started with Simplicity and nothing else. It was always Simplicity. And I've been doing that ever since at Blockstream.
You mentioned the research team at Blockstream. Who else is on the team, and what's the mission? What is the focus of the Blockstream research team?
Yeah, Blockstream Research is roughly divided into 3 parts. So we have the scripting team, which works on Simplicity and Miniscript. And this consists of Andrew Polster, who is the head of the research team, and also the scripting team. We have of course, Russell O'Connor, who is the head behind, who's the inventor of Simplicity. We have Sankit, and we have me. Then we have the crypto team. This is led by Jonas Nick, and they work on SecP and zero-knowledge proofs. Besides Jonas, we have Tim Ruffing. We have also a little bit of Sankit, and Liam Egan, who's the latest addition to the research team. And then the third part is the independent people. They do not belong to teams. And there we have Eric Sirian, who's behind Fedimint. We have Andrew Chow, who you should probably all know by now. So he's a Bitcoin core developer. And we have Chiara Bickers, and she communicates the research to the outside world. And like I said, I'm in the research team, so in the scripting team. So I work on Simplicity and Miniscript.
Shifting gears to focus on simplicity, I saw that Russell O'Connor previously described simplicity as the programming language so simple that it fits on a t-shirt. I have that t-shirt, and I feel like I'm a bit like a kid in Asia with random English on the t-shirt. I have no idea what it all means. Is that accurate? Does the whole thing, is that the whole thing on the shirt?
It's not the whole thing, but it's almost the whole thing. And I mean, this t-shirt brought me to Blockstream, so I love this t-shirt. I should have brought it. I didn't. It shows the 9 combinators, which are the building blocks, and it shows their rules of inference, so to speak, how they work. So it shows how you can combine them, their syntax, and how you can evaluate them, which is their semantics. And it's true that simplicity, I've implemented simplicity at least twice in my life from scratch, which does not count Rust simplicity, which is where I'm working on, which is the real library. And I think Andrew Polster has done the same. So we have implemented this more than once in a couple of days. And we have Burak, who you might know, and he's completely new to simplicity. And he took, I think, 1 or 2 weeks from literal zero, to build a simplicity edition add-on to his ScriptWiz IDE, which is impressive. And so anybody can implement simplicity pretty easily. There are some caveats, of course. There's a lot of DDoS protection. There are these so-called jets, which we are going to talk about, which also have to do with consensus limits and all these things. But the basic footprint of simplicity is extremely small. This is the selling point of simplicity. It's simple, as the name implies, and it does very much with a small footprint. It can it's able to do all verification we want to do on the main chain. So it's I sometimes call it verification complete. It's not Turing complete, but it can verify any condition you might have on the main chain. And so you can, for instance, what you can do is you can have a Turing complete off-chain computation and verify that this computation was correct on the main chain. And simplicity can do that, even though it's only consists of these 9 combinators of the small set that fits on a t-shirt, which is impressive. So this small footprint also allows it to be verifiable, which is the second selling point of simplicity, right? So it's small. There are not so many rules in simplicity, and because of that, you can actually formally verify every step. If we had 1,000 rules or even more, like in the EVM, it would be infeasible. It would be possible in theory, but it would be such a pain to formally verify that you are doing everything correctly. But in simplicity, you can do that. So this is how it all fits together. We have the small footprint, we have expressivity, and we have verification.
So at a very high level, it's more mathematical and kind of describes the how more than the exact execution. Is that?
Do you mean the t-shirt?
I mean, yeah, the simplicity as it's expressed on the t-shirt.
It mainly shows you these so-called combinators, which is what simplicity is made out of. Those are sort of the atomic functions, the keywords, so to speak, of the simplicity language. And they allow you to manipulate these simplicity values, which are the data. And combinators are basically simplicity functions. So they are, what they evaluate is a simplicity kind of function. And functions work on data to produce other data or to verify data. In the end, we have some data, which is witness data. It's signatures, it's pre-images, it's whatever you might want. It could be is your knowledge, a roll-up state transition, and you verify that this is correct. And inside the verification, you have maybe a SHA hash or something that takes inputs and produces outputs. And this is what the shirt shows you. It does not show you how you can integrate this into a blockchain, and it does not talk about the use case, but it's pretty general. So you can take this t-shirt alone without knowing anything, basically, and you can implement an interpreter. And this could be like a Python interpreter on the command line, where you put inputs and you get outputs. And then you could think about how you integrate this into a blockchain. What
is the use case? What's the grand vision, the plan for simplicity? I've heard Adam describe it as potentially the last soft fork for Bitcoin.
That's a very exciting topic, the last soft fork. And it's partially true and partially false. So simplicity, what it gives you is expressivity, right? So right now, every layer 2 comes with a new opcode, comes with extensions to Bitcoin script, because apparently we cannot do what we want to do on layer 1 right now. And we want to change that, right? There's a need for more functionality on layer 1. But at the same time, we all know that this is dangerous, right? We have, for instance, an alternative, which is the EVM, but it does all these things that we might not want. And it's unpredictable. It has state, it has gas, and all these things that we don't want on Bitcoin. And so Simplicity massively extends layer 1 using a very small footprint, which you can verify. And we actually proved that you can compute any verification, any function that verifies data on layer 1. This is not a conjecture, this is actually a proven fact. And so Simplicity is able to be as expressive as you might want. And like I said, we can verify that what we're doing is correct. So sure, most scripts on Bitcoin right now and also in Simplicity will probably be pretty simple. So it's going to be key spend, it's going to be an HTLC, something like that. HTLC is already pretty complicated, but you can do much more complicated scripts, but you don't dare to, right? Sometimes there are millions of dollars worth in Bitcoin on these contracts, and you don't want to take any chances. And so a good example is Miniscript, which we might talk about as well. And Miniscript gives you access to Bitcoin script functionality that has existed for years, but people didn't dare to use it, like time locks, because it's just too dangerous. You might lose your funds in a few years because the time locks are incompatible. You have an unspendable UTXO, and you realize it only later, and suddenly you have lost funds. With Simplicity and with Miniscript, we prevent that by actually proving before you make the UTXO that you can spend it in the future. And why last software? What does that mean? So Simplicity gives you these 9 combinators, these building blocks, to compute any function that you might want. And there is a caveat to this, which is consensus limits. So you have, you imagine these combinators, they are like keywords, and you combine them to form a string, a Simplicity expression. And most of these expressions are pretty large. At some point, you have a very large expression that doesn't fit into a Bitcoin block, or you don't want to put this into a Bitcoin block. And so most expressions are actually disallowed by consensus. So what do? We introduce shortcuts, which we call jets. And these shortcuts basically compress a large expression into one small shortcut, one small atom. And we say, if we see the shortcut, we actually execute a dedicated optimized C code. And we prove formally, because of Simplicity's formal nature, that this optimized C code does exactly the same as this very large expression that we could not put on the blockchain, that might be too large to pay the fees for. So we have a catalog of jets, and we have the combinators, and with this we can combine them. We can express quite a lot. We have the jet catalog will include elliptic curve functions, arithmetic, introspection, all these things. And with this, for most things, for let's say opctv or any pref out, you wouldn't need a soft fork. You could just use the jets and the combinators to combine them in some form. For most of these use cases, you can just deploy this on the blockchain right now if it had Simplicity. And if you want to optimize it later, you can already deploy it. You can already see how it works. You can deploy it for years. And then later, when you decide this makes sense, you can introduce a jet for this specific purpose to compress it even more. So this is what Adam meant, I think, by the last soft fork, because Simplicity makes many soft forks just no longer necessary. You can skip them because you have the power of jets and combinators to do a lot within consensus. Where this is slightly wrong is, of course, that there are still limits. So if you have something that is very large and you just cannot express it with the jets we have and with the combinators within consensus, then you can introduce a new jet. And this is a new soft fork, but it's possible. You can add new jets, and when Simplicity is deployed, it will have a large catalog of jets, which should serve it for the next years or even decades. But if we ever want to extend this, this is possible. And yeah, and then we can do even more. So this is the last soft fork, and how we can extend it.
So the idea is it would give you enough flexibility to do almost anything conceivably that you'd want to do in the next 5 or 10 years.
It's difficult to predict what people might want, but we have been developing this catalog of jets for many, many years, and Russell O'Connor is behind this project. This project is pretty old by now. It's, I think, the beginnings. It's unclear. Different people have different numbers, but as far as I know, it's maybe 2013, 14. So it's almost 10 years old, maybe even 10 years. And it's not obsolete yet. So these ideas are good ideas. And we will have SecP. So one of the things we will do is we will open up SecP so people can use these internal functions. And this will enable all sorts of applications. So we're pretty confident that we can cover a lot of use cases for the next years and decades. But of course, it's not guaranteed.
Does that also apply to APO and CTV? And maybe before you get started on an answer to that, can you give people a little bit of background on what APO and CTV are and what they're trying to accomplish?
Yeah, I will try. So maybe start with OpCTV. So OpCTV is this covenant proposal by Jeremy Rubin. And basically what it adds is it adds this new opcode to Bitcoin script, which gives you access to a certain hash, which is based on the transaction, in particular the transaction outputs of the spending transaction. And you check the UTXO you spend has some hard-coded hash, and you check if the spending transaction hash, this OpCTV hash, matches the hard-coded hash inside the UTXO. And if they match, you can spend the coins. Maybe you have some other spending conditions, but this is the idea. And what this does is what this enables is you can force the spending transaction to have certain shapes in the output. So you have this tree of, I think they're called transaction intents. So when you make the UTXO, you actually already know how the UTXO will be spent or can be spent. And this tree is finite, and it's not a recursive covenant. So, but there's just a technical detail. So you can make a very large tree without any space. The space is still the same because of the hash. So you can make a very large tree. You can, it's like a state machine. So the coins move from this state machine to this space. And at some point, I suppose they leave the space and become normal Bitcoin again. And you can build vaults with this. So you can, you have a cold storage wallet, and where you have your coins. And whenever you want to spend your coins, you say, actually, when I spend them, they need to enter this temporary state where there's a time lock. And if a hacker tries to spend the coins, then I can detect this on the blockchain and put them back into the vault. And also, you can only withdraw 10% or a certain amount of the total coins. You cannot withdraw all the coins. This is general true for all kinds of covenants, also for Upvolt and other covenants. But this is what OpCTV would enable, and just many other things as well. And any prefout is a very different proposal, which I'm slightly less familiar with, but I think I know the rough idea. So it's a SIG hash mode. So this is SIG hash mode, any prefout. Right now in Bitcoin, we have 6 combinations of SIG hash modes. SIG hash all is the most well-known SIG hash mode. And so when we sign a transaction, we actually don't sign a transaction, we sign a transaction hash. And we can control which parts of the transaction go into this hash and which don't. With SIG hash all, basically everything goes into this hash, and we sign the entire transaction. So we commit to this entire transaction, we cannot change it anymore. But we can also only sign a certain input, and then the other inputs or the other outputs can change. And with any prefout, what we do is we don't even sign our own input. We only sign that we use an input like we use UTXO similar to the one that we used right now. But anybody, a third party, can take a transaction, which is already signed by us, and they can exchange this UTXO with a similar UTXO, which is probably owned by me as well. So if I have UTXO A and B, I sign for A, they can actually plug in B instead. And this works. And this enables things like L2 channels and many other interesting use cases. So this is any preferred and OpsCTV. How can simplicity help here? What is, well, we can implement this in raw simplicity. So SigHash modes, for instance, are an interesting use case of simplicity. So we have a blog post about universal SigHash modes, which is, but any preferred is a very particular SigHash mode. And any universal SigHash mode means any. So we can do not only any preferred, but we can do any SigHash mode that is conceivable. And we can even extend this notion to include things like delegation, where instead of just, we can delegate, we can make a UTXO, and while we make this, we put in this functionality to give the coins to someone else without a transaction. And of course, we can control who that person is. So we can, it's not a free fall. It's not anyone can spend, but we can transfer our coins to someone else without a transaction using these universal SigHash modes, which is quite interesting. And of course, we could implement any preferred quite easily in simplicity. And OpsCTV needs some introspection, but like I said, simplicity comes with introspection jets, and using standard introspection jets that are not tailored for OpsCTV, we could easily combine them in this way that computes this template hash, or I'm not sure what the name is, but they compute some kind of hash. And we could do the same in simplicity without a soft fork and try it out on a testnet or on a local machine. Another interesting aspect of the last soft fork is something that I alluded to earlier, which is you can prototype a new soft fork, a new opcode, so to speak, which would be NuJet in simplicity language. You can prototype this using the combinators. And like I said, the combinators are universal. You can compute any function with it if you ignore consensus limits. And on a testnet, you can do that, right? And on a local machine, you can do that in a local network. So a very interesting use case of simplicity is a specification language and also a prototyping language for new opcodes and new jets, where you, instead of writing some C++ code that you merge into Rust Bitcoin, Bitcoin Core, I should say. Instead of doing that, you write a simplicity expression which computes your opcode, which computes this, let's say, OpsCTV functionality or any preferred SigHash. You build that. You can deploy that on a testnet already, as long as consensus limits are, out, as long as they're disabled. Maybe it even works with consensus limits, but in a general case, you might want to disable them, which is fine on a testnet. And you can test this out, and then you write the optimized C code, which is the jet. You ideally write a proof that this implementation is the same as the original large simplicity expression that you deployed on testnet. And then you do a soft fork on Bitcoin. That's a specification language aspect of simplicity, where you prototype a new soft fork. You can already use it on a testnet. And then you already have strong guarantees even before you make the BIP, even before you make the proposal, which we don't have right now.
So this is a very, very broad question, but what do you think are the functionalities and the applications of simplicity that you think will really move the needle in terms of disruption and just more generally market interest?
All right. That's an interesting question. Yeah. Simplicity is a little bit hard to wrap your head around in terms of applications, because it can do anything, right? So anything is a little bit of a hard sell, and anything is not even true, because we have consensus limits, we have jets, and we implicitly already decide on certain applications that we focus on, that we allow and that we disallow. Although the catalog of jets is a community decision. So in the end, it's up to the community to decide on which jets we want and we don't. But simplicity will be very interesting in terms of I guess, financial applications, which I'm not an expert on, but it can do a lot in that area. So we have a limit order project that uses simplicity. I haven't worked on that, but they're making good progress. I have talked to zero-knowledge projects, so ZK Sync and also other rollup providers that are thinking about deploying this on Bitcoin. And they are very interested in simplicity. So you can write a zero-knowledge rollup verifier, which is a new layer 2. And on layer 1, you have this, what hooks it to layer 1, what pegs it basically is this simplicity script, which verifies that every state transition in the rollup, which is basically a sidechain, is valid using some snark or stark. And this is all implemented in simplicity. The Zcash modes are huge, like the universal Zcash modes enable you to really fine-tune what you sign and what you don't sign, and everything you don't sign is malleable. So people haven't even started to really think about what this can enable, but it's huge. And one of the things I talked about already is delegation. So being able to move your coins without a transaction, that's amazing. This is actually one of the proposals that this is called Graftroot. And this was around when Taproot was proposed as like an alternative or an extension to Taproot. This didn't catch on. I don't really hear much about it anymore, but it's the same thing. So you can move your coins to someone else without a transaction.
What's the risk reward with merging simplicity to the Bitcoin main chain rather than trying to do these financial applications on second layers like the Liquid network? What's kind of the argument there?
Yeah, that's a good question. The question is also about ossification, right? So we do not want to pollute layer 1 with unnecessary scripting. There's definitely a trade-off, and the idea that we pursue with simplicity is right now, and there is a need for new layer 2s on layer 1. There's a need for like that are enabled by layer 1. So there's a need for expressivity on layer 1, and also layer 1 gives you this unique stability that layer 2s do not give you. So the idea is with simplicity, one of the things it doesn't do is, of course, it's not too complete. It doesn't give you the EVM capabilities. So it's it does verification, which is what we want to do on layer 1 and nothing else. So it's already in itself quite limited. And anything else we do on layer 2. The cost benefit analysis, I guess in the end, it's up to the community, right? But well, it's a small language. It's, like I said, it has a small footprint. It's quite a lot of lines of code that need to be merged, or that would need to be merged to, say, Elements Core or Bitcoin Core. But it's still, for what it does for rehauling the entire scripting system, it is small, and it gives you very strong guarantees about the code itself and also the language, the expressions, the programs you put on the blockchain. So it's, in a way, the smallest package you could have, which gives you the most of expressivity and also the most security. And this is something pretty unique. And this is something we think we need on Bitcoin, because Bitcoin main chain moves millions of dollars worth of coins every day without really strong guarantees. So how we work around this is right now is we use very simple scripts. We use key spends. We use the Taproot internal key or something like that. We usually don't use complicated scripts. In simplicity, enables you to also use that, and of course you can always use the simple scripts as well. So I think that's the cost benefit analysis.
Is there a risk of increased network congestion? Because I think historically Bitcoin has been, pretty basic use case, right? Maybe, peer-to-peer digital cash, maybe store of value, maybe digital gold. But as you open up more flexibility and more use cases, does that increase the risk that you could congest the network and maybe send transaction fees higher?
One of the unpopular opinions that I hold is that higher transaction fees are actually good for Bitcoin, or at least they are required to keep this whole thing going in the future. I'm not sure where the main network will go, if individuals will be able to use the main net. My vision for it is that people join groups or pools or whatever they're going to be called, and they move coins together. I'm not sure if Arc helps in that way, or Lightning, but I think simplicity will increase, or complicated scripts, large scripts will of course cost more money, and they will cost fees, and they have a potential for increasing the average fee on Bitcoin. Still, it's a much better use of fees than inscriptions, as we can probably all agree.
Yeah.
On a more serious note, the interesting or the important part of simplicity is, of course, a cost function. So we took a very long time, and we've been very careful to construct a cost function that captures the cost of each combinator and each jet. So these jets are shortcuts. So of course they look small, but they are actually pretty expensive. So we run benchmarks, and we have simplicity is again formally verifiable. So actually we have bounds. We can actually bound like how much memory and how much CPU a program can use at max, and we can adjust the fee accordingly. So we have pretty strong guarantees about the worst case scenario, which I'm not sure we would have on Bitcoin script. So we can work around this, and we can, for instance, if we put the fee to be the maximum possible cost, which I think we do right now, then we can prevent a lot of DDoS. So while simplicity will increase the average fee, I would say, at least for interesting programs, because for non-interesting programs, you can use something else. You can already use Taproot, a key spend Taproot, which doesn't use any scripts. And for anything interesting, you are going to pay fees, but they are going to be very reasonable, and you will have strong guarantees about the worst case scenario. So I think we should be okay with that.
Yeah, and I guess over time, I think, it seems like we had news this week about more exchanges integrating, I guess, kind of with the Lightning Network. I think more will look to Liquid. So we've probably got a lot of room too in terms of, how much activity we can direct to layer twos and off of Bitcoin directly.
Yeah, I think so too. I mean, simplicity will enable a lot of off-chain computation as well. So Bitcoin script just has this problem that even though it can do a lot, it's but pretty biased in what it does, and many opcodes have been disabled. And simplicity, on the other hand, is extremely general. So it does not have a public key opcode or a combinator, right? It doesn't have an AND and an OR. It's an assembly-like language. Actually, it's I sometimes call it functional assembly, and it has to be, because you can think of it as a RISC assembly. So we have a reduced instruction set, which is general enough to express anything. And then we add these jets, and suddenly we have CISC, right, with a complex instruction set. And this is what it does. And we can move a lot of activity off-chain, and we can also do very complicated things that we wouldn't be able to do right now off-chain, then verify that they work on layer one.
What's kind of the process for getting simplicity implemented on Bitcoin? What's the process, and how long does that take?
Yeah, getting it on Bitcoin will take a while. It's been a long project, although we're making. So I've joined Blockstream like in the beginning of 2021. No, 2022. I'm sorry. I joined Blockstream at the beginning of 2022. So it's been 1.5 years. And so I haven't seen the entire development of simplicity. What I've seen was amazing. We've made amazing progress, but it doesn't change the fact that it's a project that is almost 10 years old. And this is also the largest, maybe some people call the boldest proposal, the largest soft fork ever. It's a SegWit level soft fork. So this will take a lot of convincing and explanation to get this on Bitcoin. And so I think we're talking about 5 years to maybe 10 years It's difficult for me. It's really difficult for me to measure this and to predict this. But simplicity is basically teaching is a big teaching is a big challenge. Simplicity is not complicated or anything like that, but it's just different. So it requires a lot of changes in your thinking, just assuming different things, assuming different starting points, and then suddenly it makes sense. But you have to get there first. So I think we got Barak there. He had some questions. He was a bit confused about certain things. I think now he gets it. So we have a success story already. And I've been at many conferences and gave a lot of talks about simplicity. And I changed my teaching style. And I think I begin to make sense to people now. It's a lot easier now to explain it, to explain the ideas and also sometimes the meaty details of simplicity and make sense. One of the things I did is, for instance, I implemented simplicity from scratch in Rust using the Rust type system. So basically the simplicity type system can be embedded or is simpler than the Rust type system. And we have a lot of Rust programmers. Rust is famous for being a little bit more complicated than other languages, but it's not impossible to learn Rust. And if you know Rust, you actually know simplicity already. If you look at my repo. So we're making progress, and we will need a lot more of that. So a lot more podcasts and talks and blog posts and projects to get people's feet wet and to introduce people to simplicity. And of course, the Liquid integration will help a lot because we are working on a wallet. We're working on a file format for simplicity, so people can write programs, they can share programs, they can put it on the blockchain. And this will introduce people, this will familiarize people with simplicity, and I think then it will make sense. But right now, of course, it's a new project. It's old by people. Most people don't know about it. It has it can seem awfully formal, even though, like I said, they are just these formal terms sound scary, but they're actually not that scary. We have terms like a monad or something like that, or we have those are scary. But in the end, it's just we have a program that might fail. Okay, that's easy. We have a program that might return a value if it succeeds, or it might not return anything because it fails. Anybody can understand that. So if we translate these formal concepts into simple language, suddenly it will be very easy. And Russell O'Connor didn't develop simplicity to be the most complicated, but to be the most simple language. And I think he succeeded in that. So if people are convinced of the idea how to merge simplicity is as part of Taproot, this is interesting to me. I hope it's interesting to you guys as well. But the interesting part of Taproot is it has versions. So we have Tapleaf versions. So we have Taproot is an output. It has these trees. It has a tap tree. And you have this collaborative, the good path, which is the internal key. So everybody agrees, all the owners of the UTXO agree to spend the UTXO together. And this is a very simple spend. It looks like a script, just a signature as a single Schnorr signature. And then you have this tree, which consists of different scripts inside the tree. They are at the leaves. You choose one of these scripts and execute them to spend the UTXO. And every leaf has a version number. Right now, there's just one possible value, but we can introduce other versions and we can introduce new rules for each version. So simplicity comes with a new version number. And whenever we see a leaf with this simplicity version, we actually call the simplicity runtime instead of the Bitcoin runtime, the Bitcoin script runtime. So this is how we integrate it into Bitcoin and also into Elements as part of Taproot. And this means we get all the benefits of Segwit and of Taproot. This makes it a much smaller upgrade compared to introducing a completely new kind of UTXO.
And what has feedback been like from the community? What are the primary criticisms? Is it just that people don't want Bitcoin to change or its use case to change at all? What's the main pushbacks you get from people that you've encountered?
I'm happy to say I haven't received too much pushback, but I've been at conferences where technical people are interested in this kind of research. So I think the average person, I might be wrong about this, but the average person doesn't know about simplicity yet. So there hasn't been too much pushback. One feedback I recently received was this question: do we even, well, basically what you said, is it worth the cost? Do we even want to change layer 1 at all? And my answer to that was, we do want to change it because we have some major problems in layer 1 right now. We even have to have a hard fork at some point because of the timestamp problem, because of the timestamp format. It's 32-bit, so we'll run out at some point. And like I said, we have all these layer 2s that cannot be built right now. But this is one of the pushbacks. Do we even need this arbitrary computation? Can we not do this all on layer 2s? I guess it's an open question. We think that this small footprint, this expressivity and formal verification will make Bitcoin with simplicity future-proof and will be very important for Bitcoin. But of course, there are different ways how you could do this. You could even implement simplicity deployed on layer 2. So we have, for instance, we've been talking to Fedimint, and they're interested in a simplicity module at some point to control their federations. I heard something from RGB as well. So there are different. You can implement simplicity in different environments, but we are focusing on, and also of course Liquid, right? So Liquid is a layer 2. So we're focusing on layer 1, on Bitcoin layer 1. Are there any other pushbacks? Well, of course, understanding. So the formal nature, it seems like sometimes like a math lecture to people, or they've been looking at, our main document is the tech report by Russell O'Connor. And it's a very good document. I read it multiple times. This is what I used to build besides the t-shirts, which I used to build my prototype. And it has everything, but it's written in a very formal style, which is correct. But I think sometimes there's value in cutting corners and making it more understandable and being slightly wrong, but still have the intuition. And we don't have these kinds of documents that I tried to write some, but it didn't work out that well. It's also a lot of time investment, so we have to really allocate our resources. We have been very active at writing blog posts recently. I think that's been a huge success, and we will continue that. And I also made some software projects like this. I call it the Rust Playground for Simplicity, and this is this implementation of simplicity using the Rust type system. So any Rust developer, programmer can check this out, and it should make a lot more sense. But people haven't looked at this yet, I guess. I hope we can raise some awareness for these things, for these resources that exist already. And then we can teach simplicity to people, because like I said, it requires some changes in your thinking, and then it makes sense. I think those are the main pushbacks. So is it worth it? And what is this thing, right?
The risk reward is a big one. I mean, just from a risk reward perspective, you'd think the safest thing to do is implement on layer 2 and not touch layer 1.
We are very limited in layer 1 with regards to the layer 2s we can build. Like layer 1, or like, we can always introduce trust, right? So we can always have a sidechain, but not everybody wants to do that. So, I mean, people are interested in these rollups because they are trustless, but they require these insane scripts, these very complicated cryptography and very complicated scripts on the main chain. There's definitely interest in that. So this requires an extension of layer 1. In the end, it's going to be community decision what people are willing to tolerate. And there's always this privacy. Everybody likes privacy, but really often people choose against privacy. So this is also a thing that simplicity offers. It offers you very high privacy guarantees, because you have a tree-based program and you only show the paths that you actually use, like Taproot. But the question is, are people willing to pay for this? Are people going to want a soft fork for this? It's an open question. So I think right now the community moves towards extending layer 1. We are not yet at the so-called escape velocity for layer 1, where we can build all kinds of layer 2s that we might want to build. I think this is the goal, and we haven't reached that yet. And Simplicity can bring us there.
Christian, one other thing I wanted to ask you about was the relationship between Simplicity and Miniscript.
Those two are very similar in what they want to accomplish, right? So Miniscript is a structured form of Bitcoin script. So we actually take a Bitcoin script and we look at if we can find a tree structure inside the script. And it turns out most scripts that are on Bitcoin right now already have this tree structure. And this enables us to do formal verification in a limited sense, which is exactly what Simplicity gives you. And Miniscript was interesting because it gives people confidence in Bitcoin script, because of course there are millions of dollars worth of Bitcoin to be moved. And even though you have features like time locks and other kinds of features, other opcodes that people rarely use, they're too dangerous to use if you are not confident that you will be able to spend your coins later. So one of the projects that sticks out is Lewe. At least it's a project that I know about. It's a wallet that makes heavy use of time locks to enable alternative spending paths. And it uses Miniscript because it makes the UTXO, it can already check that the UTXO will be able to be spendable in the future. Because with time locks, you have different formats. You have seconds and you have blocks. And if you mess up these formats, if you combine them somewhere in the same transaction, in the same output even, or input, you can make the UTXO unspendable, which would be devastating. So only now are time locks really being used, maybe besides the HTOCs and Lightning, which have been heavily analyzed. So besides that, time locks are now being used because Miniscript gives people the peace of mind that they can use them safely. And Simplicity is like that. It's a tree-based language like Miniscript. It's much more assembly. So Miniscript has these fragments which are public key or hash or time lock, and then it can combine them in ends and ors and thresholds and so on. And Simplicity doesn't have that. Simplicity has these assembly-like combinators that don't do things like public key, but they do things like execute these two functions and combine their output or something like that. This will be the pair combinator. And you only have 9 of those. You only have 9 combinators. So they have to be very general. And then you can combine, like the name implies, you can combine combinators. You can assemble them into a larger expression, which could capture something like a public key. And using that, you can actually translate Miniscript almost one-to-one to Simplicity. And you can look at a Simplicity program that was generated from this process and see, oh, actually, this part is the public key, and this part is the time lock, and this part is the conjunction, the end, and so on. In general, this doesn't work, of course, but you can construct Miniscript-esque Simplicity programs. And we have already implemented this translation. So anything you can do in Miniscript, you can also do in Simplicity, but you can do much more in Simplicity. And also the guarantees that Simplicity can give you, the formal verification goes much further because Miniscript relies on Bitcoin script, which relies on the C++ implementation. And there are all kinds of footguns and hidden challenges. Whereas with Simplicity, we can make this architecture good for formal verification. We can prevent a lot of these problems before they even come up. And so this enables us to have much stronger guarantees about the programs. We have much better, for instance, we have much better cost functions. The cost functions we use are much finer grained, and this will enable us to write very long and large expressions, put them on the main chain, and have a very fine-tuned fee for those. So they are cheap enough so people use them, but expensive enough so we don't DDoS the main chain. And with Bitcoin script, you basically only have the byte size of the script and maybe the SIG hash, the signature operation limit. So that's much more crude than what we can do with Simplicity.
You mentioned some of the resources and information that you've prepared and your team has prepared around Simplicity. Where can people, specifically developers that want to have a fiddle with this, where can they go to get access to this information?
We have a Blockstream Research website. We also have a Twitter that I'm sure you will link somewhere. There you can find the latest updates. Mainly, we also have IRC, so I'm not sure if people want to use IRC, but we have been very active there. So this is where most of the discussion on Simplicity happens, and it's open, it's public, so everybody can look and everybody can participate if they want. They can ask questions. For instance, we had one person joining recently, and they had some questions, and we looked at their programs, and Russell made a new ASCII Cinema video that was updated to explain the latest developments. In terms of websites, I guess GitHub is a good place. So we have the Simplicity repo and the Rust Simplicity repo. Those are the main repos. I recommend maybe the wiki page of Simplicity and in general Rust Simplicity, because Rust Simplicity is it's the user-friendly repo, and the C Simplicity, the main Simplicity repo, is the consensus critical one. And so it's pretty minimal and doesn't have a lot of convenience methods. We also write a lot of blog posts, like I said, so I'm sure those are Medium and on the Blockstream blog website. And on GitHub you also find my Rust playground. You find a summary of, I call it Simple Layer 2. So this was from Bitcoin++, and it has some materials from earlier years and also some interesting materials, and a survey into how we could do rollups and how we could do Fedimint using Simplicity.
That's great. We're coming up on time here, Christian. So I want to thank you again for your time today, and hope we can get some more eyes on Simplicity, and look forward to having you on again in a couple of months.
I hope so. Thanks for having me. It was a great time.